Let's see this question. This question is asked in GATE 2010 in the subject Signals and Systems. Consider the Z transform x of z equal to 5z square plus 4z inverse plus 3 and z value ranges from 0 to infinity. The inverse of Z transform of x of n. So they were asking the inverse of Z transform of x of n. They given the options A, B, C, D which are in terms of impulse response. So first write down the given equation as it is. Okay, x of z is equals to 5z square plus 4z inverse plus 3, and we know that for x of n, if we apply z transform, this will become x of z. Okay, so write down x of z equation in terms of x of n. That will be equal to sigma n equal to minus infinity to infinity x of n z power minus n. Okay, if you observe the given equation, the powers of z powers will be maximum in z square, and it is z power 0 and z power minus 1 is there. There is no z term. Okay, there is no z power 1 term. So expand this by changing the limits from n equal to minus 2 to 1, because if you substitute n equal to minus 2 here, then only it will become z power of minus 2, that will become z square. That is the reason we are taking from minus 2. Okay, if you put z equal to 1, it will become z inverse. So you have z equal to z power 2 to z power minus 1. So we have to take the range from n equal to minus 1 to minus 2 to 1. X of n z power minus n. So now expand these terms, it will become x of minus 2 z square plus x of minus 1 z, x of minus 1 z power 1 plus x of 0 z power 0 plus x of 1 z power minus 1. Now if you observe this, let it be equation 1, this can be equation 2. If you observe equation 1 and 2, on comparing equation 1 and equation 2, you get x of minus 2 as the component of z square, that is 5, and x of minus 1 as the component of z, there is no z component, that will be 0, and x of 0 is z power 0, that equal to 3. Okay, and x of 1, that will be nothing but z inverse component, that is 4. So we have got the x of n values 5, 0, 3 and 4. So x of n is equals to 5, 0, 3 and 4, where 3 is at 0th position indicated by the arrow mark. This will be at minus 1, this will be at minus 2, this will be at plus 1 position. But as I said earlier, the answer is in the form of impulse response del of n. So we need to know the relation between x of n and del of n. X of n is given by sigma k equal to minus infinity to infinity x of k into del of n minus k. Okay, here it's ranges from minus 2 to 1. So that implies x of minus 2 del of n plus 2 plus x of minus 1 del of n plus 1 plus x of 0 del of n plus x of 1 del of n minus 1. Okay, now just simply substitute the values, you will get the answer. X of minus 2 is 5, so 5 del of n plus 2, okay, plus x of minus 1 is 0, that will be 0, 0 into anything is 0. Now x of 0 into del of n, that will be 3 into del of n plus x of 1 into n minus 1, it will be 4 into n minus 1. Now you eliminate the 0, it will become 5 del of n plus 2 plus 3 del of n plus 4 del of n minus 1. So this will be the answer. If you observe in the options, it is 5 del of n plus 2, 3 del of n, 4 del of n minus 1. Option A is the correct answer for this question. Okay, thank you.